welcome to the second chapter, and we'll get started on the presentation. That's coffee. Let's see, somewhere here the presentation starts. There we go. So today we're going to try to demonstrate that organizations have a business need for information security, try to explain why a successful information security program is the responsibility of both organization in general, of the management, and IT management. We also are going to identify the threats posed to information security, most common attacks associated with those threats, differentiate threats to the information within the systems from attacks against the information within systems. And I know that you can read all by yourself, so this is just a warm-up. We'll describe the issues facing software developers, and we'll talk about secure software development lifecycle. So, who remembers the definition that we provided on Monday, a definition of security? How can we define security? What does it mean to be secure? Go ahead.
To be protected from adversities, from those who will do harm to us.
Okay, great. So to be protected from adversity. So we talked about security being an assurance that we are safe from threats and that the risks had some corresponding controls in place. And then that assurance was enough so that we had this feeling of security. All right. So security is very much a balance of risks and controls involved. All right. So today we'll talk about why businesses have this need for security. We'll talk about the different threats that are in place. So when we talked about data and the different parts of data, what were the three things that we are interested as far as providing for data? Remember that CIA triangle that we talked about? What were the three things that we want to provide for data? Availability, exactly. So when we read here that the primary mission of information security is to ensure that systems and content stay the same, right? So we want to make sure that if a resource is public, that it stays public and it is available. Now, if the resource is available under some confidentiality requirement, it still stays available, but it is unchanged. That authorization is also obeyed. So availability was one of them. What were the other two? Integrity, yes. So it needs to stay the same. It needs to be unchanged. And the third one? Okay, confidentiality. That's correct. Okay, and attacks are a daily occurrence. So let's get into more detail. Yep. All right. Business need is driven by the fact that in our current commercial culture, businesses have some kind of a model, and they need to generate income. They basically do what they're designed to do. To operate, okay, they have to do that in some kind of a level of assurance. Did you notice what happens with gas prices or the stock market when the consumer assurance level goes down? Have you ever listened to those reports? You know, why is the stock market changing? Well, because consumer is just not sure about their spending capacity, and they're maybe in fear of something. So security and this assurance that risks are in check very much affects business. IT security protects businesses' ability to function. Now that's pretty straightforward. I mean, it doesn't have to be information security that we're talking about. If you have a store and you're just selling things, right? You want your customers to be comfortable bringing in cash or bringing credit cards, and you want to provide some safe environment for them. Which is why when downtown of some city starts having issues with security, you'll see businesses slowly exiting, right? Because customers are not going to just go down the street and basically thrive in an environment. We need to protect the data that organization has. In the past, we talked about data being the most important asset that organization has. The data is more important than the servers that are hosting the data. Sometimes the data is more important than the employees that the company has on its payroll. So that's why business has the need for security. Now, why do you think that both the general management and IT management would have to be responsible for the implementation of security? Why both of those groups? Why not go to the old model where, hey, only the security administrator, is responsible for security? What are some of the consequences of getting both of those management trees involved?
You have both the technical and general management approach to it. So you have security people who make security aspects and general management, something like that. Policy, making sure that everyone.
Yeah. In most circumstances, when you are running business, security gets in the way. Okay, so you have to put a lock on your store from now on. Well, I didn't have to do that before. Why do I have to do it now? It's going to slow me down. You'll hear comments like that from end users. Well, why do I have to pick a longer password? It'll slow me down. Or why do I have to first use VPN and then connect to the application? So implementation of security is going to cost either real money, okay, you're going to have to spend some cash, but it's going to cost in productivity, right? And for everybody to be on board with that, you're going to need to have the general management involved, and then you're going to have the IT people involved. Otherwise, you basically are pushing a new way of living, okay, on people that have good reasons not to do that. Salespeople want to sell cars, right? And security is going to always get in the way. And so that's why we want to be able to marry those two management trees in order to make sure that IT is not just pushing that on everyone. All right. We not only have to have the general management involved, whatever business it is that we're talking about, we need to have the upper management involved. So what are some of the upper management positions? Who are we talking about when we talk about upper management? Yeah, so something with a C in front of it, some kind of a chief, right? Chief financial officers or chief the other chiefs, CEO, chief executive, thank you, officer. Yes, so the upper management must continue to oversee the entire infrastructure when it's put in place. The problem here that, again, we are running into is that if security becomes an IT project only, then we never are going to reach that commitment or the culture level, right, in security. Who remembers the first two levels that we discussed last week? The very first one, when you just tell people about security, that's the second one. The obedience is the second one, yeah? But the first one was when you just hear about security, awareness, yeah. So it's just an awareness program. So you can get awareness, you sometimes can get obedience, right? But people will not commit or make it part of their culture until they understand that security is really an effort of everybody. And if the upper management is not part of the implementation and the maintenance and the maintenance phase, then suddenly it again just becomes the security officer saying, hey, you have to change your password. So we want to avoid that, and that's one way to do that. All right. An organization without data loses its record of transactions. Well, hello, that's pretty pretty straightforward. And today, we have very few organizations that do not use computerized data to track their operations. So, you don't have to be an Amazon.com or Google to appreciate that. If you lose your tax records, right, that's a huge problem. If you use your customer information records, depending on the company, that could mean the end of your operation. So we can see how protecting the data makes security a core need for a business, which is a good news for you guys, because if you're going to work as security professionals, you're working because there is a real need, right? So without the real need, oftentimes jobs are not created, or those jobs are cut first, you see? So because we identify this real need to protect data, security will always be one of the core operations. All right, so organizations must have security infrastructure services calibrated to their size and the scope of their enterprise. Secure infrastructure services, what will that be? Maybe we start just with infrastructure services. Yeah. So infrastructure service, right? You can maybe think about a network connectivity, right? So there's infrastructure service. If we have phone connectivity, another type of infrastructure service. So secure infrastructure services are going to really encompass the IT services that we can provide. They have to be calibrated, okay? You can't implement the same level of security in a mom and pop store as you would in a large organization. And that's because they actually could be totally, non-productive if you take them through all the security measures. So that's why we'll talk about how to choose just the right controls for whatever size of the business we're talking about. All right, and so that brings us to threats then, because without those threats, the need that we talk about would also dry up, right? So with a constantly present threat, we can talk about the need, which was the reason why last week we talked about Enigma and why it was the Polish code breakers that broke it first, because the threat of the Germans, see, was over them first. All right, so threats can be objects, people, they can be entities that represent a constant danger to an asset. We talked last week that the weather can be a threat, right? If your data center is close to a river, like it is, or it was for a long time here at GRCC, you are in the flood zone, right? That's a threat, because at times that can actually reach your data center. Because of that, management must be informed of different threats facing the organization. Now, I like how 64% of organizations have malware infections, 14% indicated that the system penetration was by an outsider. Okay, what that shows is sometimes the threats that we consider, people really sweat the external, the Chinese hackers, and what you'll find is that all your data can be stolen by a secretary, who for one reason or another is just unhappy in that position. So the reality is that the threats on the inside are much harder to control. That is the case for most operating systems. To actually get in the operating system, find vulnerability, exploit it, and do something as the root user, it's very difficult. But if you are already a user, say, to elevate your rights, that can be much, much easier to do. So that's why those internal threats are going to be always more difficult to locate and secure from. All right, so here are some of the threats. Compromises to intellectual property For example, piracy, copyright infringement. You know, a lot of times this happens, people don't even know they're doing it, right? Here in the academic environment, we have a little bit of freedom. So I can copy and paste a paragraph from a book, and as long as I provide the source, we might be okay. But when you take it into a commercial world, then privacy and copyright infringement can be very legally charged, because now you're dealing with maybe their business secrets, maybe you're dealing with plans for a new model, and suddenly that really translate into a lot of money. So unfortunately, it's a little bit gray zone, because fair use basically allows you to use something as long as it's for educational use, if you use only part of the work. But people can get, you know, with the right lawyer, in other words, you can go after someone even, you know, if fair use seems to make sense. So usually, you know, this copyright infringement has to do with maybe backing up a video, right? So let's say that you bought a DVD and you have kids. And so in a matter of days, the DVD gets scratched. And now you're $30 behind because you have to buy the same copy of the movie. So you've learned that there is a program out there that allows you to make a backup of your own DVD. So when it gets scratched, you just take a blank DVD and re-record. So is that legal or is it illegal? Right? So depending on who's in the courtroom, I think that you could get in trouble, because technically you have the right to make a copy, but if you ever start watching a movie, you know, it'll say no copying allowed, right? So so some of those copyright laws can be tricky. So that's why piracy is up there, and of course piracy has been a huge subject with SOPA and some of the other laws, where what they're trying to do is they're trying to outlaw any copy process, right? So that they don't have to prove to you that, no, not only did you copy the movie once, but you made a copy for everybody in your family, right? And that would make it, at that point, piracy. But I started by saying that some people don't realize that they are infringing of copyright, because maybe they are creating their own website, and it's so easy just to right-click on a picture, save it, and make it part of your website. And maybe they didn't do that maliciously. They just don't understand that actually you are infringing on copyright laws. Another example is this. You hire a photographer, maybe for a wedding, right? And they take a picture of you and whoever you married, so that you remember the next day. And so you go ahead and get all the pictures taken, and then they post the pictures on their website. Okay? Now you chose pictures that you're going to buy, and that's great. And then you go on their website and you copy the picture that they posted of you in the picture, and that's illegal. Because they, as the photographer, have the copyright on the picture even though you're in it. And you cannot, without their permission and paying them, get any more copies than what you already paid for. And I bet that most people don't understand how that works. You know, they, especially when it's a picture of you. You know, why would you ever wonder about it? So other things we have in place are software attacks. Software attacks can be either automated, or they can be actually controlled by a hacker at the time when they're happening. Deviations in quality of service. All right, this is. I think this is a neat point here in our course, where performance of a system becomes a security risk, right? Because availability is part of our goal. So that's one way maybe to create a good business case for performance, for buying load balancers, for buying hardware that actually will perform well. DOS attacks can impact deviations in quality of service. But a lot of times it's just regular users. Everybody woke up Monday morning, they want to buy the shoes, right? And so then your system goes down, and we can consider that a risk in security, because it'll affect the business, you see? And so that's how we connect the dots there. Espionage or trespass. You know, when the phones got cameras on them, I mean, that just blew the lid, you know, of a lot of organizations. People would check, you have to check in all your phones before you can enter, especially companies that deal with design, like automotive and such. Yes?
My buddy works on subdigs down in Kings Bay, Georgia.
Mm-hmm.
He actually has to drill out the camera going on his, the camera part of his phone, drill it out.
Drill it out?
To prove to him that it doesn't work.
That is pretty cool. So when you buy a phone, you don't really care if it's 4 megapixel or 8.
No.
Yeah. But, I mean, today this espionage became, you know, really easy to do. In the past, you still had a camera, and you hid it, and it was really little, probably better technology than what we're using. But today, the espionage can be performed by people who are not trained to do so, right? And I think that companies that have you drill out your camera still have the threat of espionage, because people who truly are trying to steal something are not going to, you know, bring a phone with them. They'll probably have more sophisticated equipment. Yeah. Forces of nature, like fire, flood, earthquake, and lightning. It's all in the threat category. Information extortion, blackmail, information disclosure. So this is sort of the dark side of large companies, right? You might be making good money, but you might be wondering what happens to your family, right? Because if people are so desperate to get information or to leverage your position in the company to go as far as blackmail or kidnapping, all kinds of ways, you know, you may reconsider maybe some other line of work, maybe better. So information extortion. Now, information disclosure is connected here, and think about social engineering, right? Where you say enough, basically you lie over the phone until they tell you whatever it is that you need to know. It could be their password, but it could be maybe meeting times, meeting places, any information that takes you to the next step as far as executing the plan. Missing, inadequate, or incomplete information. So loss of access to information systems due to disk in place, drive failure without proper backup and recovery plan, organizational policy, or planning. So this is a serious matter, and that's why last week or Monday I've mentioned that it's necessary for a security professional to be knowledgeable in overall IT operations. So in engineering, know the RAID levels, know a little bit about backups, what's an incremental backup, what's a full backup, so that when you create a policy or when you are doing an audit, you can actually bring out what can be changed and what is not meeting the standard. Because all of this, as you can see, comes under the security umbrella. All right, missing, inadequate, or incomplete controls when network compromises because no firewall security are in place. Sabotage or vandalism, destruction of systems or information. So sabotage, again, it would be a very common place today, and it's one of the main security risks because especially when the economy changes, when it gets harder, you have to let people go, you have to cut their wages, you have to maybe demote people, or their career might be stuck in some kind of a magic cycle, and sabotage becomes a big deal. So that's why it's then so important to have a policy in place that protects you from those people who actually have valid access to files. Theft, illegal confiscation or equipment or of information. Technical hardware failure or errors, as in equipment failure. And this is where high availability, right, is an approach in technology to mitigate equipment failure. High availability can be right on the server level. You can have multiple hard drives in place, you can have multiple power supplies. All that helps you to have high availability. The technical software failures or errors like bugs, code problems, unknown loopholes. Finally, technological obsolescence as in antiquated or outdated technologies. if you look at when to implement technology, we start with cutting edge, right? Cutting edge where you have early adopters. Sometimes we call it the bleeding edge because, you know, the bugs we don't know yet about. And then you have majority. It is the early majority. So a lot of people who, after the first bugs are worked out, are planning their upgrades and are going to be in the early majority. Then late majority, and then finally legacy or obsolete technology. So the best place to be is in the early majority because it gives you most ROI on the system. You want to avoid being in the cutting edge, well, depending on what kind of company you are, but most companies avoid being on the bleeding edge. Being in the early majority, again, is the most beneficial from ROI or return on investment. But we read here that being on the back of that system, being in the legacy, being even in the late majority, can be costly from security perspective because there's a threat that when your technology is obsolete, something is going to go really bad security-wise. All right, so threats to information security. And now, a really pretty slide showing us the use of the internet, showing the population, showing how many internet users are in place, and the usage growth. And what we'll see is that every part of the planet is growing in terms of the internet usage, okay? Which is great for business because it creates new markets. More and more people want the iPhone, right? And more people are going to buy Nike shoes. And what happens is that's great for business. But this creates risks, right? It doesn't necessarily affect security immediately, but it creates new risks. How does internet growth and risk relate? What types of risks do we have when everybody is worldwide is using internet more and more?
Nigerian scams.
Okay, Nigerian scams. That's right. So these scams that basically are the forward fee scams, and not that rarely the Nigerian scams actually come from another part of the U.S., right? They just say they're from Nigeria. Yes, so scams, more scams, because when there's a larger population, larger audience, if your scam is only 1% successful, then that's still a lot of money when you send it to millions of people, okay? All right, so scams are a good example. Any other risk that increased internet usage would cause?
More viruses, more espionage.
Excellent. Well, in fact, the more people are involved, it's like getting everybody in the room, okay? The more people in the room, all risks are going to go up. Even the weather. I mean, see what happened where are most of the hard drives made? It's not Malaysia, it's Thailand, right? I mean, when Thailand got hit, then the prices of computing went up, and there was a risk that opened up for all kinds of elements. So now that we're connected worldwide, we are there's more risk that the weather would affect our business. All right, but that's the reality. And actually what's happening is there are more and more wires being laid across continents, increasing the capacity of connections, and as a result, we have the numbers that continually grow. All right. So we're going to take more details of those threats. IP, not as an internet protocol, right, but IP as an intellectual property. It's actually a very interesting concept and something that we just spent a little bit of time on, but you should probably read up on how to protect your own intellectual property. For example, if you have an idea and you publish it on the internet as a web page even, you don't have to include the C copyright sign. Ideas are automatically protected when published, right? So the copyright is yours. But there are different understandings or different different things involved with implementation of an idea, okay, or an idea itself. You actually can't protect an idea, but you can protect the implementation of it, right? So when you buy a patent, you actually protect the implementation of a specific idea. Today, I think in some industries, like in software generation, in software writing, intellectual property has changed a little bit. For example, with open source, people will publish the whole insides of the software, and they're not concerned with intellectual property being lost. In fact, they feel that when they expose the intellectual property, they can sell more of their pieces, and companies will hire them because of the intellectual property that's exposed. So in the past, intellectual property was a huge deal. If you wrote Windows, then you were going to guard that code because it means millions or billions of dollars in licenses. Today, this is changing a little bit, where the more people see good intellectual property and they can see the inside of the software, then they are more assured about security. They are more assured about ability to maintain this code over a longer period of time. So of course, software piracy is a huge deal, especially abroad, right? Piracy is very much dependent not just on the original moral code that people are raised with. Okay, it's not that people in other countries are somehow broken in their mind so that they steal because they love doing that. Okay, really, piracy is very much dependent on the ability to pay for the software. All right. If you look at Office itself, I found a report somewhere where it was showing how much people have to pay in this country for Office, and in Ethiopia apparently it's many years of someone's income, right, to actually buy Microsoft Office. So if you can't afford the software, right, then people will reason their way out of some of these moral codes that would say you can't steal. And that's why piracy is actually fairly, fairly popular in countries, and they don't even consider that stealing. I think it reminds me of a fairly annoying commercial that Disney was putting on their DVDs. I have little kids, so I have to watch that. And there, they show there's some music, like it's an action movie, and they say, well, you wouldn't steal a car, you wouldn't steal this, but you're downloading music from the internet, right? Because at some point, for whatever reason, people stop thinking about piracy as stealing, right? Maybe that's because they can't afford it to start with, or maybe they just don't understand it, like teenagers who download MP3s from the internet. So many reasons why piracy becomes a very difficult thing to manage. All right, so we have a couple of organizations that are going to track the piracy market out there. The enforcement of copyright law has been attempted with technical security mechanisms. Right. I think that's why Adobe Flash is going to stick around. You've heard about Adobe sort of going away. Well, look at all the books that are being published through Flash. And that's because they have security mechanisms that allow you to only view this book for a period of time. If you try to do that on an HTML page, right, I'm going to put some JavaScript there. That's going to secure it. So it's much more difficult to do that with other open technologies. And these mechanisms, of course, already exist in the media player, right? So you can buy music, and that music is then tied. iTunes has mechanisms of this sort. So to basically enable through technical elements that the intellectual property is protected. All right, so that takes us to deliberate software attacks, malicious software, or malware. So malware is going to be the large umbrella of all software that either on purpose or not on purpose, is going to cause harm or try to steal data. So malware designed to damage, destroy, or deny service to target systems. Viruses, worms, Trojan horses, logic bombs, backdoors, trapdoors. The one that I want to spend some time on is the polymorphic and then polymorphic threats. So let's look that up briefly. All right, so polymorphic code is code that uses polymorphic engine to mutate while keeping the original algorithm intact. That is, the code changes itself each time it runs, but the function of the code will not change at all. So this technique is sometimes used by computer viruses, shellcodes, and computer worms. There is another way to hide the signature of a virus, and that's through a metamorphic code. Let's see if we have that here. Metamorphic. Okay, and so here the computer virus is able to reprogram itself. Okay, here's why these are different. In polymorphic code, oftentimes the virus is going to encode itself differently or even encrypt, but it's actually the same code. So before the code can be executed, it has to be decoded and it has to be decrypted. And then before execution, a lot of times the virus protection software, if you have the real-time enabled, can catch it. Because what virus protection companies will do is they'll take a program that they know to be a virus and they'll take a hash of it, right? So they'll try to identify that program so that that hashing function can be rerun through the program quickly. Let me show you what I mean by a hashing function. Okay, so let's see. Okay, so there is a file here called grc.zip. All right, and let's assume for a moment that this file is a virus. Now, if you were a virus protection company and you were trying to make sure that no other Windows system ever gets this file onto the hard drive and executes it, how could you identify this file? What are some of the features of the file that you would be looking for? Size and name, exactly. So I can see the size of the file, and I can even see the name of the file. And those, originally, you know, when we had the first versions of virus protection, that's what they were looking for, because that was really the only way to try to look for these files. And today too, you know, when you find a virus on your system, you a lot of times will take the exe and you're going to Google, you know, what is this? And so we're looking at the name of the file, maybe even the size of it. But that's very easy to change, the name, right? Name is easy to change. The size is easy to change too, because all I have to do is maybe add another echo or a print command or print F if it's C to go ahead and change the size. So there are functions out there. One is called mdsum, that when you run it against a file, and it doesn't matter how large the file is. See, that's the beauty of these hashing functions. It doesn't matter how large the file is. It'll give you a little signature. Okay, and so now you actually are scanning the contents of the file and not just the file name. Right, so the contents of the file. If the contents changes somehow, then it'll be a different hash. So now the virus companies can put in their database that this specific hash is a virus. Well, that's fine and great until the file is somehow changed, right? And so what we see under polymorphic code is that temporarily the file can be encoded into something else. But if we have now metamorphic code, okay, now we're in trouble. The pattern of recognition right, that is otherwise available for the polymorphic code is not going to be there. Suddenly, this program is smart enough to rewrite itself and to recompile itself so that it looks like a brand new program. Right? And that's how then it'll be much more difficult to actually catch, to create enough virus definitions to find it in the future. Which is why today there is a lot of computers that have been hacked, and they're being exploited for DOS attacks and things like that. So I think we're going to get to the point where you're going to have a virus on your computer, and that virus will protect you from other viruses, because they will care to have most of the capacity of your system to do their attacks. It's a little bit like the mafia people that walk by and say, for this much we'll protect you. And it'll probably work pretty well. Yes, Andrew?
I was reading about a bunch of different worms last night, and there was one that downloads and installs Microsoft security updates. And they were saying it's been classified as like a non-harmful worm. It'll sit and update your computer for you. I couldn't figure out why you would do that.
Well, so here's what I would do. If I was already on the box, I would go, okay, close all the vulnerabilities. We're already here. Okay, now we have to keep this computer very secure so that when we need to get something done, right, no other viruses will be in the way. Yeah, so those are interesting conspiracy theories, and we'll see. We'll see if this ever happens. Okay, so the other things we have are Trojan horses. When you think you're installing a game, and it looks like a game, it works like a game, but it also is a virus. Logic bombs. So let's say that you installed a program and the program is dormant until a date comes along, or until a condition is met on the system. Your CPU goes to almost zero, right? When these conditions are met, then the program will do whatever it needs to do. Backdoors. So if I'm installing a program, not too long ago, some Microsoft products like Excel, they had these Easter eggs. Remember those? All you had to do is just type in a specific set of cells with characters, and they would show you maybe an animation, or it would show you the names of the programmers. I don't think they do that anymore, okay? Because there was a back door, and so software can have back doors where I wrote it, and I know that if I issue these commands, the software will actually act differently than what it normally should do. All right. So viruses and worms. What's the difference between a worm and a virus?
Virus attacks the system, a worm attacks the network.
Yeah, you could say that. So a worm is there's a network necessary. For a virus, you don't really have to have a network. You can just bring on a USB. So a worm is really designed to propagate to other systems, right? So it goes in one place and it's going to jump to other systems. A lot of times then the worm requires that there's a vulnerability on the system that's open, whereas a virus can get into a perfectly secure and updated system, because if you write a batch file that does something malicious, it could be considered a virus. All right. Here is a beautifully documented Trojan horse, right? Trojan horse arrives via email or software such as free games. Everybody picks on free games, right? Free games, you have to pay for a game to really have security assurance. Trojan horse is activated when the software or attachment is executed. Trojan horse releases its payload, monitors computer activity, installs backdoor, or transmits information to hacker. Well, that may as well be a virus in terms of how that's described. But basically, if you look back at, who was it, the Greeks and, Helen of Troy. It was the Greeks and there was some other, Trojans, thank you. Right, and so you couldn't get in at all. So what they ended up doing was they put all the soldiers in a big horse, and the ships left. So they thought that, hey, this is just a goodbye gift. They pulled the horse into Troy, and then at night the soldiers came out and did their job. And so I think that's great when hackers learn history, and when you actually, like promoting culture, That's important. But yeah, this will happen because you can make people download things and install if they think they know what they're doing, if they get a little bit of benefit. Here's web shots, right? Hey, I'll change your background, or some silly things like that. Weather bug. I mean, all kinds of little software pieces that people think they need. And so you create a piece of software that somehow they think they need, and then you can add to it whatever you want. So multiple issues involved there with lack of security awareness even on the end user's part, but also a certain level of neediness, right? That people end up installing whatever they think they need. Now, one thing I think is changing in the industry to address those issues, and that is what Apple did with their mobile technology, right? By introducing the App Store. What's great about the Apple App Store is that before software can be released to the App Store, there's a team of people that actually take a look at it, evaluate it, and then they will release the software. In order to even release software to the App Store, you have to be identified. You have SSL certificates. They identify you. You have to sign your own code so they know who you are. And then you have to pay, I think, $100 a year to be a developer, right? So automatically, this sets up some kind of a standard for developers. I think Android missed the boat on this whole design, right? So with Android, you can put whatever not working app or Trojan horse on the App Store, and it'll actually run and execute. I think we're going to see more and more operating systems going more towards the kind of Apple Store protection, because for security, it does help, right? When you see an app for iOS, you have some assurance. Again, we talked about assurances that we can make that the risk was mitigated somehow.
I'm always worried about that. That criticism has been around since Android, Android first came out. Why isn't Google going to have the resources? Why won't they? I mean, have they ever said publicly why they won't follow that model?
So unfortunately with Apple, they get things right over and over again, but everybody sort of hates the way they do things. Like you pick up an Apple phone and you can do maybe 20% of what you can do on Windows Phone or Android phone as far as functionality. But that little that you can do is everything you need, right? Also, Apple decided not to have Flash on their devices. Okay, now Flash is going away, right? So they continue to call things well, but it all takes money. So to be an Apple user, you have to pay for the hardware, you pay for the software, and there's only one company it goes to, so there is not open market in terms of, hey, I can't run my iPhone app on other platforms. And Google has always taken on the idea, don't do any harm, And with open source, the whole idea of having to pay someone to distribute your apps, it doesn't yet compute. So security yet is not where we were talking about, where you connect business and security. You can't part them. So a lot of times with open source or with sort of the openness of Android, business is there, yes, in the openness. Security is not. So I think they're trying to keep their commercial and otherwise market image as a very open company. Now, if that means that a lot of their phones are not working well, or maybe they're not as secure, that's just the risk that they're willing to live with. But I agree that I think as we go forward, we should see more of these. Why not have a Windows App Store where Microsoft has some blessed apps, and so for people who don't know any better, they only should be buying the certified applications. Yeah.
They're actually talking about doing that with the Windows 8 release.
Windows 8.
They're actually looking at doing a comparable App Store type platform.
Yeah, because for security-wise, it makes good sense. Alejandro?
Isn't that why Apple's more secure than the Windows products? Or at least I'm being unaware.
I think the reason why Apple's secure is because they're on Linux. All right, that's first. But when you have smaller percentage of market, then you are going to be more secure. If I'm a hacker and I'm trying to control an army of botnets, hacking Macintosh computers is not the answer. So you want to hack what is the most of out there, which would be the Windows systems. Yep. Did you have a thought? Okay. All right. So Trojans basically pry on users' inability to distinguish good software from bad software. Deviations in quality of service, when products or services are not delivered as expected. So this might include denial of service attacks. There are examples of large portions of the internet going down when human errors take place. Maybe the routers are updated with wrong code. So sometimes this type of a security issue is not published, right? Because it just means downtime. Most of the time, we are looking at when data is stolen. That's when things get into newspapers. But this still is, the quality of service is still under the security umbrella. All right. So more issues. I like this right here. Communications and other service providers issues include other utility services which affect organizations' telephone, water, wastewater, trash pickup. When the electrical grid went down, right, you could clearly see how there's a connection between services and security, right? So that's why companies today, I think a lot of times don't make that connection. They look at security as simply making sure that data doesn't get in the wrong hands. But as time goes on, I think we're going to see the quality of services being more of a security considered issue. All right, so power regulations, fluctuations in terms of the power quality. It says that all organizations with inadequately conditioned power are susceptible. Okay, so at home, how do you condition power? Do you have ways of doing that? Yeah, so a surge protector would be a way to condition power. There are other devices, especially if you know anything about audio equipment. There are special devices that, not just surge protectors, that basically make sure that the power that goes in is properly conditioned, because for audio recordings, and maybe if you're doing a DJ work, you want to make sure that there isn't too little power, too much. It's going to be actually audible, at that point. Yeah, so quality of service for power. Espionage or trespass, well, it means to have access or protect information by unauthorized individuals. Competitive intelligence versus industrial espionage. Industrial espionage, it can be as easy as, let's say that you have two bookstores competing, and you have managers, walking through the other bookstore to see what they're doing and how they are advertising similar books, and trying to figure out how to do it better. I don't know if you've ever seen, there are people who will scan prices in even grocery stores, and managers of those stores will ask them out of the store, right? Because inventorying your prices means that someone else is going to try to undercut those prices or create, whatever condition that. There's an app. Well, there is, but it's. I'm talking about, let's say, guys from Walmart going to scan prices in Meijer, and then being able to say, "Hey, come to Walmart because those 20-inch TVs are cheaper here," right? No, I'm.
It's the same thing, like with the Amazon app, you take the
Yes.
scan and it comes up on Amazon flag right there.
It's called Shop Savvy, and you can get it on Android or iPhone, and you can scan a barcode and it'll tell you where in the area or on the internet something is cheaper. And so that's true. I wouldn't consider that espionage. That's probably just good shopping, background information. Espionage is when you would see. It talks about competitive intelligence. So companies are trying to have a competitive edge or market edge, so that when someone comes to a store you can, you don't have to have all your items cheaper. But when someone has the idea that, hey, look at these 2 items, they are cheaper than at the other store, they think that they will actually do better in this store. Well, the bottom line is that your other items may be more expensive, right? So the large stores operate on the idea that they count how much money you've spent on the visit, not just on specific items. So when you can adjust the prices in your store so as to undercut maybe the higher prices in the other store, you see, that's where the espionage comes out, and the market edge is lost. Therefore, your value on the market may, and that may result in losing customers. All right, so shoulder surfing. Here you are at an ATM, right, putting your numbers in, and everybody's watching. Shoulder surfing, most programs try to avoid shoulder surfing. So if I was to try to log in, and this of course is not, let's see, there isn't a user of this sort. Oh, that's nice. All right, so let's just do this. I'll probably get a phone call for doing that. But now, if I type anything, a password, you can't see, right? So most systems today have some kind of a protection for shoulder surfing, so that when you are typing a password specifically, the characters don't come up. On phones, a lot of times, they'll show you the character and then they'll change it back to some kind of a masking character. And that's done again so that when someone is maybe looking over your shoulder, that they don't see the entire password. On the keyboard, you can see where people are clicking, so you can figure out that a little bit. That's shoulder surfing as well. Most web applications, and we can go to not Blackboard because I'm there already. But let's say we're going to log into the online center. The password field is masked. It's masked because if someone's looking over your shoulder, we don't want them to know what you typed in. All right, so that's shoulder surfing. Controls let trespassers know they are encroaching on an organization's cyberspace. Ooh, that sounds like a very important part. So, for quite some time, before you logged into a Unix system, it would have this little message. It would say, welcome to, whatever it was, like GRCC. And hackers used that as an excuse, saying, no, they were welcoming me. They wanted me to do it. They wanted me to get in. Really. And so then, security administrators required that you either set access denied or that you remove any messages prior to just saying username. Okay? So that's why it's important that the perimeter of whatever it is that you're protecting is somehow marked. Otherwise, and later on when we listen to an interview with a hacker, these hackers, again, in their minds, just like people that do piracy, somehow they have reasoned out that what they're doing is actually not illegal, right? Like, I was just exploring, I was maybe trespassing, but not stealing. However they reason that out, you have to let them know that going beyond this point is illegal. So just like showing maybe at your house no trespassing sign, right? If you put the sign down, then you can reasonably expect that you communicated where the perimeter is. Hackers use skill, guile, or fraud to bypass those controls which protect private information. So that we're going to discuss as we go forward. An example of shoulder surfing. This does not have to be shoulder surfing. It could be a camera, right? Even from a distance, that's actually collecting some of that information. All right, and here is a really rather important distinction where we have a traditional hacker, rather young, basically someone who is using a computer and notices how easy it is to do certain things. And then we have a modern hacker with a profile, basically you can say unknown, right? Because the ages from the time you can start typing to the time when your hands are, so arthritis-driven that you can't type, and male or female, unknown background, and so forth. I think we're seeing a change here in what hackers do, why they do that. What do you think were the motivational factors of the traditional hacker? Why were hackers doing the things they were doing in the past? For fun. Yeah, fun was very important, because when you imagine maybe 3 kids in middle school running around, if there is a fence and it says do not enter, right, they're going to be sitting there thinking, what's behind that fence? How do I get in? And maybe they will trespass, right? Well, that's the same on the computers. They basically see FBI. What is, it's like Homer Simpson. How do you spell FBI? And so they would actually try to get in places just because they couldn't do that. Now today this actually is changing, because we have now generations of hackers that were taken to prison for doing that. And so hacking is obviously something that's dangerous. So when people do successfully hack somewhere, they no longer reveal that in a bar or wherever they go, which is why that profile is going to be more and more unknown. But we know that we have more hacks than before, right? More and more people are on the internet, more companies take their business on the internet, and this is an unknown profile. 2, I would say that in the past the law was a little bit behind. They really didn't understand electronic crime. The laws really weren't written for them. Today we have more and more legal tools against hackers and illegal cyber activity. There are police departments that all they do is cyber activity, which is why, these people choose to be anonymous. So we'll see how that affects this field in the future. All right, expert hackers versus unskilled hackers. What do we call unskilled hackers?
The ones that get caught.
Script kiddies, the ones that get caught, yeah. Yeah, so they call them also skids. Skids being script kiddies, sort of in one new word. Sometimes a network administrator has to be a hacker, because there might be a system that is not responding well, and then all the skills of a hacker, like port mapping and checking versions remotely and all these things, those are valid skills that they might have to be using. And so unskilled hacker, unfortunately, this is the population that makes that gives really a bad name to hacking, because they are the ones that will just run rootkits and other programs and cause just destruction, basically. And that's not for making money, so they actually don't benefit in any way, typically get in trouble, and we're not moving forward the understanding or knowledge of hacking, because they are reusing the same code. All right, and so that's where we meet now. Crackers, someone who removes software protection designed to prevent unauthorized duplication. So cracker really means a little bit more than that, right? So we talk about cracking passwords or doing brute force attacks. Cracker for maybe a DVD movie might try to break some of the encoding or whatever the license protection is in place. But it really, today, cracker means also someone who breaks in and destroys. And the really historical expression of a phreaker who is going to try to hack the public telephone network. Fortunately, phones are cheap enough today that we don't have to do that, right? So there's again where the piracy and ability to pay for software are also somehow related. I think if people could afford all the software they need, you would see piracy to be fairly marginal, because who doesn't want to have the updates for the software and the legal copy so that you can rely on it. And so that's why public telephone networks are no longer, I probably shouldn't say that, but maybe you disagree, but I don't think people crack telephone networks as much today, as they did in the past. They had those blue boxes that were designed to allow you a phone call anywhere you want it. All right, forces of nature. Here is an important subject because that's something that we probably will never be able to control, right? So those are the risks. Doesn't matter how much education you provide, those will always be the risks. Some of the new forces of nature not only have to do with the weather, but think about disease control, right? When SARS hits and all your network engineers are out, right? Those are new types of risks that are introduced, and something that will have to be policies built to support. Of course, the network engineers are always in danger of buses hitting them, so there's a health risk involved there always. Human error or failure, yes. Inexperience, proper training, incorrect assumptions. Human errors happen all the time. One thing that I've noticed is that in many IT offices today, when you are full-time, you're being worked really hard, okay? And when it's 3 a.m. and you've been working for the last 10 hours, your skills are not as sharp, okay, or even thinking ability is not as sharp. So the human errors do creep in. So you say RM-RF and you didn't realize the directory you were in, and that will happen. So a lot of times human error can be mitigated by the correct or good design in high availability. So even though I've deleted these files, there is actually a way to get them back, right? So human error that way can be somehow mitigated. All right. Employee mistakes. Sometimes if your policy actually does mention the punishment, right? So we're now at the obedience level. You actually can mitigate some of the human errors. Because revealing classified data, which should be kept private, or entry of erroneous data, some of that does simply require a little bit of education and people paying attention, right? And so that inclusion of in policy of what the consequences are somehow can generate that. Okay. Who is the biggest threat to your organization? Hopefully that's not you, although some will claim that, because the amateur hacker or the convicted burglar, they all have to go through a lot of hoops to actually steal the data, right? But the employee that accidentally deletes the one copy of the critical report that's there, that is still not the worst scenario, right? The worst scenario is when this employee is copying the entire database, taking it with them, and holding it hostage. Now this has happened where in California, I forget which city, was it in San Francisco? Yeah, so there was a network administrator who was about to get fired. He goes down and changes passwords on all the routers, right? And says, okay, fire me. Refused to give the passwords back. Won't tell them. And so now the city is in trouble because these routers, for whatever reason, needed to be changed, or they felt like without having access they couldn't continue. And you can see that the risk for the organization was very high. And yet this guy is holding the passwords hostage. So they put him in jail. And he wouldn't reveal it because now he feels that if I actually reveal the password, then we're done. So I believe the way I remember the resolution is they actually came to resolve it between themselves. So somehow they came to understanding that you guys give us the password and we'll let you live. Some kind of exchange of that sort. But it's the internal employees oftentimes that will be able to do that. Well, for whatever reason, whether the routers were driving some important infrastructure, okay, or people just didn't know how to do that. But you're right. I mean, most devices allow you to reset passwords. Not Windows. right? If you forget your administrator password on Windows, the instructions say reinstall, right? Of course, then you pick up Backtrack or some tool like that, and you can reset Windows. So you use Linux to reset password on Windows. But yeah, some, by following manual, some of these devices don't have the kind of reset capacity. But I think there was more involved with that than just that. I think he had it programmed wrong or whatever it was.
Yeah, he had a whole bunch of stuff. He locked it down pretty tight before.
Right, before leaving, yeah. Right. Okay, so attackers steal information from computer systems and demand compensation for its return or non-disclosure, commonly done in credit card number theft, information extortion. So people have to be really desperate to do that, right? Because 12 months later, when all the credit cards are expired, somebody's going to knock on your door, and maybe authorities will be with them. Basically, when people are mistreated at a company, and they're in some kind of a negative emotional mode, that is not the best place to be to make life decisions, right? And when you decide to blackmail or steal information, that is a live decision you're making. And what's going to happen is, when you've been convicted of a cyber crime, that's going to stay on your record, and you can kiss goodbye your technology career, right? So it's actually a big issue these days because, again, when the economy goes down, people are put in all kinds of difficult emotional situations. And so that's, I think, where information security becomes that social science, because you need to know how people are going to react in situations. It can be as simple as, what is our policy for letting people go? And I'll give you an example here at GRCC. I think it was maybe 5 years ago. 4 people were let go from the IT department. I think officially in the newspaper it said that it was for efficiency, right? In reality, there was some consultants that came in to make it more efficient. So these 4 people were getting fired, and care was taken that all of that was done on one day. But what they did is they asked 3 of them to HR, and the 4th one went out to lunch. All right, and when the 3 people were being processed in HR and their access was being taken away, the 4th person came back to the office, to the technology office, and people looked at them and say, "Aren't you getting fired today?" And that people lost it. I mean, they basically became unstable emotionally, and it just didn't work out really well for that time. So that element of human behavior, becomes very important, because then, someone takes a ball bat to the servers, and you might be in some, real trouble. So some of these policies are going to, again, include the general managers and other departments to make sure that it's all synced. But it's a social science, because we need to know how people are going to affect security in different situations. I'm not really at freedom to disclose that, but it ended okay. I mean, you definitely don't want to learn that you're being let go from other people that are just surprised to see you there. So yeah. All right. So now, missing, inadequate, or incomplete. When we have information that is passed and it is not accurate, it's sometimes worse than not having the information, right? So it talks about omissions within IT control areas that can make an organization more likely to suffer losses when other threats lead to attacks. Well, all that means that we need to make security a science, right? So we need to operate on systematic processes. So if you do it one way, there's always the same result. The moment the database is corrupted, it might be difficult to keep it secure, right? And so there might be losses due to that, and then there are threats to other attacks, because when the database is corrupted, well, maybe you have to turn some security areas off just to make sure that maybe that's not in the way. A very popular way in Linux is to turn off SE Linux when you see errors. Something isn't working, turn off SE Linux, and a lot of times it'll start working again. So that's why incomplete, inadequate situations and information is going to cause to future attacks, and sometimes we leave systems exposed because now I turned off SE Linux and it works. I'm going to get back to that tomorrow, right? And then the system is exposed and vulnerable for that period of time. All right, sabotage or vandalism. Here's where we have maybe a little bit new term, a hacktivist or cyber activist. Have you guys heard those terms before? Any examples that you can think of hacktivists or cyber activists? What's that?
Anonymous.
Anonymous, yeah. So there are actually companies that will invite people. Because if you create a program to send an email somewhere or hit a website, right, that's actually hacking, right? That's illegal. But you can ask people and say, okay, everybody, write an email to this company, and when you have millions of them, right, that's no different than a denial of service attack. But that kind of activism, I call it hacktivism, it's popular even with regular mail. Think about when people are taken to prison in maybe developing countries. Organizations will write letters to the president or whoever is in power. So it's not necessarily illegal to do some of those cyber activist campaigns, but you definitely have to know the law and where the line is. If you're crossing to the illegal section there. Cyber terrorism, much more sinister from a hacking, and it is on the rise from nation states. Well, it's interesting that cyber terrorism. So it's hard to distinguish what's cyber terrorism and what's maybe a denial of service attack. That's based on more monetary or commercial activity. When a company pays to have another website shut down, is that cyber terrorism? A lot of times it becomes cyber terrorism when you start hitting strategic, nation installations. Maybe their ability to communicate with health information or their ability to deliver services. But we'll see probably more and more cyber terrorism and jobs created around them, because countries like Iraq, countries like Afghanistan, sooner or later will be full of computers. Just like Russia is full of computers, and we see a lot of attacks happening in those areas. And I'll bring some examples of recent cyber terrorism so that we can later on talk about these. All right, so here's an invitation to be an activist on your computer. And so these recruitments do take place. All right, theft. Electronic theft is a more complex problem. Evidence of the crime is not readily apparent. So just like stealing intellectual property, right? If I know the new model of the car that you are creating, I don't have to just recreate it and sell as my own. I'm going to build on it and make my car look much better. And so it's difficult often to prosecute. It's difficult to detect. And that's why we're going to probably see more companies try to protect their data than try to prosecute later on, right? So the protection of it is going to and the avoidance of having to deal with a problem. That's where jobs will be open for making sure that encryption is very strong, to make sure that the perimeter and network protections are strong as well. All right. At this point, let's take about 5 minutes break. If you need to visit the restroom, that's a good time to do that, and we'll resume after that. Okay. Okay, so welcome back. At this point, we discussed a number of threats. There's still others in the queue, but I wanted to share with you this interview with Kevin Mitnick, who is sort of a very traditional hacker who is now a security consultant, and he does talks about how to do security well. But I think he is back from the times of the traditional hacker, basically unaware of what's happening and what the consequences are. And as you listen to some of his answers, you'll see how confused he is about what it is that he actually was doing. Again, it reminds me of kids, running through some fenced area just because they want to. So let's take a look at that.
Kevin Mitnick was probably the world's most notorious cyber thief when he was captured in 1995 and sentenced to 5 years in prison. Over a 13-year period, Mitnick broke into the computer systems of more than 35 major international corporations and other organizations, exploits that made him the FBI's most wanted computer criminal. When we first sat down with Mitnick in January of 2000, just before his release from federal prison, he told us that he saw himself not as a devious criminal, but more like a merry prankster.
I saw myself as an electronic joyrider having a great time on the information superhighway. I felt like I was like James Bond behind the computer. It was a big game and I was just having a blast.
Did it ever occur to you that perhaps what you were doing was wrong?
Oh yeah, it was an invasion of privacy. Going and getting access to other people's information is obviously a gross invasion of privacy and it is wrong.
And that didn't bother you?
At the time I was doing it, no.
What Mitnick was doing was breaking through the highly sophisticated computer defense systems that companies use to protect their trade secrets, which he repeatedly stole. His list of victims reads like a who's who of big business. They include Motorola, Sun Microsystems, Nokia, and software maker Novell. All told, the companies estimate Mitnick cost them $300 million in damages.
I believe I caused some damage, but nowhere near that number. I was an accomplished computer trespasser. I don't consider myself a thief. I didn't deprive these companies out of their software. I merely made a copy without doing anything more with it.
You stole it.
I copied it without permission.
You didn't steal it. That's stealing, Kevin. That's stealing.
I didn't use it for financial gain, nor did I cause any harm.
Beyond his skills as a computer hacker, what also made Kevin Mitnick so effective, according to the FBI, was his phenomenal ability to obtain confidential information from corporations by phoning unsuspecting employees and simply asking them for it. It's known as social engineering. How would you describe social engineering?
Well, basically lying on the phone, manipulating or conning information of people over the telephone.
So you were a good con man.
Yeah, I was successful.
Mitnick was hacking and conning his way into corporate computer systems 10 to 12 hours a day. And while he held down legitimate jobs working with computers, he says hacking was like an addiction, which eventually became the most important thing in his life. At one point, Kevin, you got married, right?
Yeah, 1987.
Didn't work?
Well, no. I mean, initially it was great. I loved her very much. But what really broke up the marriage was I kept going back to my hacking. That became a higher priority.
By the age of 25, Kevin Mitnick had been arrested 3 times for computer fraud. In 1989, he spent a year in jail. He was then placed on probation in order to receive counseling. He attended a 12-step program for his apparent addiction to hacking. It didn't work. He continued hacking. A warrant for his arrest was issued, and he became a fugitive, the FBI's most wanted cyber criminal. For more than 2 years, no law enforcement agency could catch him as he hacked his way across the country, assuming new identities. But eventually, the FBI was able to track him down. And in the middle of the night on February 15, 1995, a team of FBI agents knocked on Kevin Mitnick's door where he was living under an assumed name.
I think the guy goes, "Are you Kevin Mitnick?" I go, "No." I said, "Go look on the mailbox. You got the wrong department." And then he brings out this wanted poster of Kevin Mitnick, right? And he's like, he goes, "So isn't this you?" So what am I going to say? Yeah? You know? I go, "Well," I said, "the nose looks a little bit the same, but everything else, definitely not me." And I handed back the poster. He goes, "Well, tell you what we're going to do. We want to take you down to the FBI and fingerprint you. And determine whether you're Mitnick or not." I said, "Great. What time do you want me to show up in the morning?" And they go, "No, we want to take you down."
So the social engineering skills hit a brick wall, right?
Oh, absolutely. A very good place to stand.
Soon after we spoke to him in January of 2000, Mitnick walked out of jail a free man after having served almost 5 years. But the government wasn't finished with him yet. We'll tell you more about that when our update continues.
Tonight's update is sponsored by Zelnor. Ask your doctor about Zelnor.
The restricted his career prospects were uncertain. That is, until the federal government came looking for him once again. But this time he had no reason to run because they wanted his help.
My name is Kevin Mitnick. I appear before you today. I was released from custody January of 2000. And just a few months later, I was invited to testify before Congress.
What you're telling us is that all of our systems are vulnerable, both government and private.
Absolutely. And after that, a lot of businesses, I guess from seeing me on C-SPAN, were interested in having me speak about security.
And so a new career was born. This is a video Mitnick uses to market himself to potential clients.
So a lot of you probably already know about my past. I was involved in computer hacking. The purpose of my public speaking is to raise awareness to what the security threats are, how the bad guys operate, and what you can do to protect yourself.
Mitnick maintains he no longer does any illegal hacking, but that hasn't stopped him from playing a hacker on TV.
We have Kelvin gives someone access to a bogus website.
Appearing on an episode of Aliens. And in real life, Mitnick freely admits that he's still breaking into other people's computer systems. But these days, he insists it's by invitation only, and it's legal.
I'm an ethical hacker today, and what I do is I essentially get paid to hack ethically to find security vulnerabilities in my client systems and notify them so they can fix them.
No longer on probation, Mitnick is not only busy consulting and speaking, he's also written a book on computer security and is working on a second.
Kevin Mitnick has grown up. Took a little while, but I finally did.
All right. A couple of things that I want to talk about here. One is, now that we know that he basically was doing things for fun, did you notice, why did he, what happened to his marriage, and why did that happen? Did you catch that? He obviously got divorced and all that, but why? What did he give as a reason for that? Yeah, addicted. I appreciate you using the word addiction, because one of the measuring pieces for whether something is addiction is you ask yourself, does it affect my work? Does it affect my family life, right? And then it's an addiction. And so for many of the hackers, this activity, whatever joyride or whatever, you're James Bond, becomes an addiction. Well, now we're entering a whole new, area of understanding these folks. And a lot of times, when you go to the courtroom and you say, well, it's a health issue, it's an addiction, it actually, for some, it actually works to be viewed differently. But yes, these hackers today, however their business model has changed, is not just being there, it's actually stealing data that costs money and can be monetized. It's an addiction because there is a high that's gotten from breaking through and making systems do what you want to do. Okay, let's do something different now. If you can open your textbook on page 54, there is a report here, Hack PC Week, which talks about an exercise that PC Week basically thought up. They created a server, right, where they have a website running. In fact, they had two of them. They had a Linux one and a Windows one. They created some infrastructure, and they challenged people to go ahead and try to hack in. And this particular hacker is giving us step by step of what he has done to actually go ahead and get in. What I want you to do is go ahead and read this. You should find technical terms and technical processes that are new to you. All right? So I'd like you to look into some of them and see if you can find answers. And there is a place here, the Hack PC Week. If you click on that, I want you to answer these 5 questions. Okay, which technical element was unknown or confusing to you in this report? What exactly this technical process or element means? And please explain to us, like we're 3 years old, right? So if they're talking about buffer overflow, how do we explain that to someone that may not know much about technology? And finally, which skills and JFS is just his handle, do you think can be used in security industry? What could PC Week security and engineering team do to prevent this hack? So at the end, when you read about what the hack was, what could they have done to actually prevent it in the first place? And I'm not looking for something like hey, disable JFS's IP address, right? Let's just look for something that they could have done as part of their research so that systematically it can be implemented, right? Maybe it's keeping the versions of the software up to date. And then, is there anything else you still are not sure about in this JFS hacked report? So please comment on other questions that people have posted. That way, as you read other people's blogs, you might able to respond to the elements that they don't understand. Okay, so it'll create a little collaboration on this blog. All right. If you don't have the textbook with you, we have how many people don't have the textbook? All right, good. Let me try to locate this article on the internet here. Okay, so let's get back to some of the other threats. We're going to take a little bit faster pace. Hardware failures and errors, just like the quality of service, right? High availability is a good, all right then. High availability is going to be a good cure for that. Let's see. What if I want to start here? Okay. I want to start here. Okay. Yeah, there we are. Oh, there's a human errors. Extortion, sabotage. There we are. Software errors. Of course, this is much easier to come by, and it's far more common than hardware errors, and can cause quite a bit of issues. Technology obsolescence. So antiquated, outdated infrastructure can lead to unreliable, untrustworthy systems. It simply is the case that as technology goes forward, people will stop producing fixes for old software. Vulnerabilities are published, and then they're well published. Fixes are not published. Also, as hardware gets old and as software gets old, the speed of computers goes up, and therefore it's easier to crack the older software and hardware. So again, being in the early majority for implementation is going to be best. All right, attacks are acts or actions that exploit a vulnerability, which is an identified weakness. It can be accomplished by threat agents that damages or steals organizational information. Malicious codes or hoaxes, any of those are going to be considered attacks. Now here we have the idea of an active web script, which is intended to steal data. How does that work? How do web scripts, and likely we mean JavaScript today, how can JavaScript steal information? Okay, so there's data in the browser that's stored. A lot of times JavaScript doesn't really have access to the data that's in the browser, though. First of all, the way it's executed is, if I can put JavaScript in a comments field, submit it to a comments forum, and if that comments forum does not sterilize the data, so they don't check whether you're submitting text or code. And when you submitted code, and they published it automatically, then that code executes on the page that someone else will be viewing. And then, when someone else visits that page, that code can simply say, what is the cookie on the current page? That's legal. JavaScript can do that. But the next function is going to say, redirect me to some other website. And at that point, and that can be done through redirection or through AJAX, but basically there's a request made to an external website that can carry your cookie from the current session. That cookie can be a session cookie. And a session cookie basically identifies you with whatever website you're logged in with. So then, your session cookie is stolen. Just by having that session cookie, I will be automatically logged in to that Amazon.com or Facebook or whatever the application is. Now that I'm logged in as you, I can change your password so that you can't log in anymore. Or I can maybe try to generate whatever the application is capable of. You can continue your attack from there. But that's the idea of a web script, and what I just described is called a cross-site scripting attack. XSS, cross-site scripting. Yep, and for some reason they spell it XSS and not SCSS. I think a CSS attack would sort of be a cascading styling sheet attack. Oh, yeah. So it's cross-site scripting. All right. So here's some other methods of attacking. IP scan and attack. The infected system scans a random or local range of IP addresses and targets any of several vulnerabilities known to hackers or left over from previous exploits such as Code Red, Back Orifice, or Poison Box. So once one computer in this classroom gets a virus, it can scan, ping, use ICMP to identify other computers on the network, and then it's going to try on specific ports to execute code against a vulnerability. Okay, web browsing. If the infected system has write access to any web pages, it makes all web page content files infectious so that users who browse to those pages become infected. So the way that happens is, as you download a page, I can include an object tag. And that object tag can include Flash or ActiveX controls or some other code that's going to actually make the virus part of your environment. Virus itself, each infected machine infects certain common executables or script files on all computers to which it can write with the virus code that can cause infection. So there's again where you can take Notepad and you can put that Notepad in a wrapper code. And the first function of the wrapper code says execute Notepad. But then the next line says, and also do some of the other things. Therefore, the program still looks like Notepad, and it starts up Notepad, but it also executes other functions. Unprotected shares, using vulnerabilities in the file systems, the way many organizations configure them, the infected machine copies the viral component to all locations it can reach. So, what Windows computer can have mapped drives from multiple systems. And with a mapped drive, now this virus or the file executable gets put onto external shares. Other people, as they have mapped those shares, they will double-click, execute, and in fact, they'll spread the virus. Mass mail, by sending email infections to addresses found in the address book. The infected machine infects many users whose mail reading programs also automatically run the program and infect other systems. Outlook is a program that basically was notorious for this. You would get strange emails from people you knew, which is how it went under any filtration systems. So this program would say, hey, look at the picture I took today. Because it was a person you knew, you would open it. And at that point, another virus is executed, and everybody in your address book gets the same email. And so that's why today we have, live mail. You know, they basically even gave up a little bit on the name Outlook. I think Outlook Express was pretty much commonplace to do that. Simple network management protocol. By using the widely known and common passwords that were employed in early version of this protocol, the attacking program can gain control of the device. Most vendors have closed these vulnerabilities with software upgrades. So SNMP is such a cool thing because it tells you the CPU on the remote system. It can tell you the hard drive space. It can alert you when things are happening. It was so great and cool that companies would deploy it very quickly. But the major fault here is that you should always change the default password. If you don't change the default password, then someone doesn't even have to hack. They just try the default password. Oracle database has this user called Scott, and the password is Tigger. All right? And I remember back, about 99, our production database still had the user enabled, right? So you just go in and you are logged into the production database. Now, that doesn't mean that you have the rights immediately to the rest of the system. But as I mentioned before, once you have the initial access, you can elevate your rights with more ease.
That's like the admin.
Yeah, that's right.
You drive down the street and then
admin. And that works. A lot of times there's no user at all, just the password admin. Now if you get AT&T device, it'll have a sticker on it with a unique username and password. So over time, people learn a little bit. In SQL Server, for the longest time, the user was SA, and I think the password was the word password. And so in SQL Server, full access, to the system. Okay, other attacks, backdoors, password cracking. I think the textbook somewhere has a nice picture of how long it takes to crack a password. That if you are using just characters on a I think 6-character password, it takes seconds to get in, to find the password. Just by trying AAAA, AAAB, AAABB, and you try all the combinations of permutations of the characters, and you find the password sooner or later. What do systems do to prevent password cracking? Yeah, so after 3 times, you're locked. And this is how you can lock the whole company really in a hurry, right? So you just, instead of cracking passwords, you provide 4 times the same password, and you do, the cracking of the user ID. And in time, you've locked the whole company tight. Don't do that, by the way. That's just a thing other people will do. Brute force, it's, of course, when we try the cracking of the password. Okay, dictionary attacks. There is a program called John the Ripper, and it has dictionary files. So depending on what language you're operating in, language as in country, not programming language. you get a dictionary, and then out of the dictionary, it'll first run simple words, then it'll put words together, and then it'll put words in phrases, and then when that fails, it's going to start doing the brute force just by characters. Okay. Denial of service attack, and then distributed denial of service attack. This is something that you can buy on the internet today. So you log into gaming forums and you say, 5 days downtime for grc.edu. Or, you don't want to turn in your homework on Monday, bb.grc.edu, buy 5 days of downtime. And people that have botnets, they can execute that. And if you give them your credit card, to charge for that, you must be high on something else. But basically, you can purchase and buy those types of services.
I remember hearing something about somebody attempted that with a denial of service attack on Amazon, and they couldn't bring it down. There weren't enough bots. Because I think it handles so much traffic with what they were doing at Christmas time.
Yeah. And that is possible. When we earlier talked about how security is related to performance, and how downtime is considered a security threat. So there's a number of techniques that you can use to prevent a DOS. One is called fencing. Basically what you do is you continually analyze the traffic. So if I have a lot of requests from one IP, and those requests look synthetic, you cut the IP, right? So by fencing, you can actually prevent a lot of denial of service attacks. In the past, I've seen browsers get in a loop, basically like a JavaScript loop, and not intentionally they would produce, it was a bug in the software, unintentionally they would produce a DOS attack. And so then we created some scripts that it was a natstat command, and it would count how many connections you had from each IP. If you had 100 connections from a single IP, that automatically generated an IP tables command to cut it off, and the local firewall will basically drop the packets. So maybe they do something like that to actually disable the bots instead of handling the traffic. But then if they have high availability done right, then yes, maybe they have enough capacity to handle most of the DOS attacks. Having said that, if the DOS attack is staged just right, you are not maybe just making requests, maybe you're downloading a large file from hundreds and hundreds of computers. There are always bottlenecks to go for. If your database is strong enough, maybe your network connectivity bandwidth is not big enough. So when you do it just right, you probably can find the right secret sauce to bring something down, or at least make it appear like it's down. Okay, so distributed denial of service basically means that instead of trying to run like the AB command in Apache, which is Apache benchmark, where you can, from one computer, you can send thousands of requests, you use multiple computers. Because just from your one computer, a lot of web servers take it as a single connection. So they will only budget so much memory for that connection. But once you do that for multiple computers, they have to open multiple HTTP daemons, and that might, in fact, shut down the system easier. All right, spoofing. A very easy way to spoof is to install a Linux server, and then you can use PHP to write a simple mail command, and in the from field, you get to say what you want to put in, and you can put anybody's address. And you say, refresh the page, and the email is going to go out to whoever it was in the to field, and it'll look from whoever you put in as from. Gmail allows you to do a little bit of it. In the past, I don't know how much you use Gmail. In the past, you could link multiple accounts, and you could say, hey, I would like to send email as someone else. Now you have to still log into the mailbox and confirm. But in the past, Gmail would actually spoof the address so it would look legit. Today they will say so-and-so via, and then give your Gmail address, right? So they're trying to limit the spoofing capacity. PGP fixes this. Okay, pretty good privacy, because then you have a private certificate that you keep, and then you distribute your public certificate to everybody that you'd like to exchange emails with. And when your email goes to their mailbox, it contains an attachment that was encrypted. And then they can verify that it came from you, because well, it can be verified, and therefore your email system will show like a checkbox or some visual, cue that this is a verified address. Man in the middle. SSL fixes this problem, right? So man in the middle is when you use a telnet session, it's all clear text, and someone connected to the same hub can see all your traffic. Whereas when you do it via SSL, even if they get a copy of your traffic, they cannot see what's inside of it. They can't decrypt it. Spam, I don't think we have to explain that. Everybody's dealing with it all the time. Mail bombing is similar, basically. This time we are sending a lot of email for the reason of bringing the mail agent down. Okay, here is something that is not done very easily, and that is to spoof your own IP source. Spoofing email address is very easy. Spoofing the IP source is difficult. You have to have access to higher level routers. You can't do it from your own house, because all the packets that come out of you go to a router that's going to know something is fishy, right? So if you have access to the core internet routers, then you can actually spoof your IP address, because you end up sending packets that normally would be sent by someone else. You send those packets, the IP header is changed, and they go out and they start being routed like anybody's traffic, which is sort of the downside of the internet today, that as the router, you get traffic, you just see who's writing to whom, and you just forward that. There isn't much in terms of authenticating that, which is why the spoofing still works.
Can you release or renew your IP address?
Well, so in this situation, the hacker is trying to hide their IP address, but most of all, the hacker is trying to gain access to a firewall which was configured to allow a specific set of addresses. This specific set of addresses is nothing that you will get from a DHCP server, because these addresses are somewhere else. And so by hard coding another IP address or refreshing, you might actually shut down your system, because then your system won't be able to communicate with the local network. So instead, you do this at the router level, where you say, okay, override this header, and then this fake packet goes out and moves across. Yeah, Andrew.
If you spoof your IP, right, is it traceable still? Like, at some point, does it track back to like your ISP where it originated from?
Well, it is a difficult situation, because as a packet travels from one router to another, the MAC address gets overwritten, right? So really IP is what we go after. So it might be difficult to trace it back. So what's possible, if you have your own IP address, then we can trace it back right to your workstation. But if you spoof the IP address, it might be more difficult, because there are so many packets being discarded all the time in routers that no one really keeps a history of them, so as to track back where this packet came from. Having said that, it takes, you have to have the right equipment, the right internet connectivity to be able to do that. Okay, example of man in the middle, and of course it had to be male, because otherwise, the name wouldn't fit. But basically, it's someone who has access to the physical media between you, right? And so if it is wireless, someone needs to have access to the wireless or to the wire, and then they will process the information first. But again, SSL most of the time will fix this problem. Here is a great example. Load balancers. Load balancers do man-in-the-middle attack on purpose. Okay? What they do is, let's say that you have an SSL certificate on the server, and then the workstation is trying to talk to you. Well, as the workstation talks to the load balancer has the certificates on it as well. It'll decrypt the information, and it'll forward to the correct system, encrypt it back forwarded. because it has multiple systems to work with, and so it has to know what goes where. So on the load balancer, oftentimes we decrypt in on purpose so that we can put it in the right place. But of course, to do that, you have to have the certificates, the private certificate, on the load balancer and then on the servers as well. But that is sort of a legal implementation of man-in-the-middle load balancers. All right, sniffers, phishing, and farming. These are pretty straightforward. The phishing example here, we have a letter from Nigeria. I actually got a letter from Spain where someone was claiming that one of my ancestors, who actually died in 1800s, okay, they claimed that he recently died and there was some money to be split, and all I needed to do is just provide some documentation fee. It's the same idea, right? They want you to send some money. It's a advance fee type system. But genealogy websites are used for that. They'll look up who in your family is there. Also, they will use things like automotive postings to do this kind of fee forward problem, or even job sites. Hey, I have a job for you. All I need for you to do is just become part of this organization or whatever, and this is how much you would pay for doing that. All right, that takes us to social engineering, because people are your weakest link. You can have the best technology firewalls, intrusion detection systems, biometric devices, and somebody can call an unsuspecting employee. That's all she wrote, baby. They got everything. Okay, so people are the weakest link, but in a way, people also are the strong link, because we can think out of an algorithm. We can think about some of those hacks that are not yet put inside of a firewall. So we are the ones also to create the defenses. So it's the weakest link, but it's also the part of the chain that can strengthen it. All right. At this point, I want to move to another part here. Oops, let's see. Full screen. And I want to show you this short video that actually talks about something called SQL injection attack. It's a little bit important for us to see that.
Well, when I click on login, it says your password.
All right. Well,
hello, my name is Joel Helgeson with Appian. I've been commissioned to
so I'm not sure why this looks
do a
so
web
awful.
server security audit. The information that I've discovered, if you click.
Give me just a moment. I'm going to try to fix it. For some reason, it's really, really pixelated. That's not how it's supposed to be. All right. All right. This guy right here. And what happens if I blow him up like this?
Hello, my name is Joel Helgeson with Appian. I've been commissioned to do a web server security audit. The information that I've discovered, if you click on eNorthwestern here, notice that it says username and password. But let's try a common SQL injection technique where I do hack for 1 equals 1 hyphen
All right.
hyphen.
Give me a moment. I'll figure this out here. What in the world? Let's see if I can find that. All right, there it is. Sorry about that. I thought it would have worked there. Oh, man. Well, we might need to. Well, what I'm worried about is that you can't see what he's typing here. What he's typing in there is fairly important. It's just if this is the text box, he's putting a single quote, which in SQL basically you put strings in quotes. So he ends a string, then he says or 1 equals 1. Okay, and so what that means is that the select statement that gets generated, something like select all from some table, it'll say where password equals, and then in a single quote, it's going to put in whatever is the variable that comes from the form. Well, when the form includes already a single tick, it's going to put it right here. So then it'll say then password equals, stop the password. Then it says or 1 equals 1, which is always true. So then the SQL command actually is going to select the very first record in the database. And so that's why that's what's
I'm going to copy
missing there.
that. Control C. I'll type in the word me, and then I'll paste this, Control V, into the password field.
He did it in the username
Well,
because
when I click
it would be
on login,
masked.
It says your password can only contain numbers, letters, or the underscore. Well, that's not good enough for me. So what I will do is let's go in and click on View Source. Now that I have the source in front of me, I'm going to modify a few things. I'm going to be viewing the page offline, so I'm going to do HTTPS Okay, that's because I'm going to be viewing this offline, and I'm going to go ahead and take out some of this information that I don't need, which is on submit if
So he's taking the validation out of there.
if any of the information passes back as being false. This is the information that, if I enter my information incorrectly, it's going to return back and saying, you screwed up. I'll also take out this JavaScript. I'll scroll down to here, and right here is some more JavaScript that I just want to get rid of. Get rid of all that script. Text password, type password. I want to change that to type text. And max length, I need more than 10 fields, so I'll do 11. Now that we've made all the modifications, I'm going to save as c:/hacked.html. Now we're back to our browser window. I'm going to type in file://c:/hacked.html. All right, now I can type in whatever I want here, and because I enabled the text field, you can see what I type there. I type in hacker, and for the password I type in whack or 1 equals 1 hyphen hyphen. I have now disabled all authentication, and by logging in, it comes back with the first record in the database, which is Allison.
The hyphen hyphen is needed because hyphen hyphen is a comment in SQL, because you have whatever the rest of the SQL here is, which could be a sort, and especially it's the finishing tick right here. So you basically are going to insert your code right here, and this last hyphen you have to comment it out. That's part.
I can take a look at her grades. And right there's her social security number. Oh, you can see she was born in 74.
All right, so that was about SQL injection attacks. Often what you can do is you can say where username equals, then provide your own username, and then password, close it, and then or 1 equals 1. And so then the record for that user will be found, and then the password validation is disabled. So you actually log in as that particular user that you're looking for. All right. Now, how can you fix that? How can SQL injection be fixed? Well, for one, you can validate for input. So do not allow single quotes as part of the password. And you will see that most applications don't allow that as part of a password. Secondly, you want to do this validation on the server side. Don't do validation with JavaScript, because he can override whatever you had, right? So when you validate on the server side, you can actually validate better, and it's a real validation. Okay, so that takes us to all I had for today. And what I will do is I'll find the original version of this show and link it to the class so that you can see more detail. I'll see you next week, Monday. The assignments are due before our class starts on Monday. And yeah, we'll see you then.